special right triangles. So yesterday we just did regular right triangles. Today we're going to learn about special right triangles. There are two types of special right triangles. The first type is called your 45-45-90 triangle. In a 45-45-90 triangle, both legs are congruent, and the length of the hypotenuse is radical 2 times the length of the leg. So if we show that on here, it says both legs are congruent. So that means these legs are congruent. You guys learned what type of triangle this was. You should hopefully be saying this is an isosceles triangle. Okay? So if it's an isosceles triangle, that means the angles are congruent. Well, if the angles are congruent, then they both have to be 45 degrees. So the theorem about the 45-45 is if you have x's here, then your hypotenuse is going to be radical 2 times one of your legs. So if you come over here, you can write that formula down. So leg times radical 2. And then if you think about it, if you want to go backwards, you want to find a leg, you would do the opposite of that. So you would reverse it, and you would do, in order to find the leg, you would take the hypotenuse, and you would divide it by radical 2 to move backwards. So I like to draw little arrows on my triangle. So going forwards, we multiply by radical 2. Going backwards, we divide by radical 2. Okay? Alright, find the length of the hypotenuse of a 45-45-90 triangle with legs of length 5 radical 6. So we know it's 45-45-90, so it's an isosceles, and we know the legs are 5 radical 6. So I'm going to fill this out. 5 radical 6 here, 5 radical 6 here, 45-45, and we want to know x. We want to know the hypotenuse. So we are moving forward. So if we move forward, we times by radical 2. So I come over here, and in order to find the hypotenuse, or to find x, we take a leg, 5 radical 6, times it by radical 2. And then we multiply those. So 5 radical 12. And this is why we need to remember how to do a simplest radical form, because we have to break this down. So break down 12 gives you 4 times 3. 4 is your perfect square. So that would give us 5 times 2, times 2 radical 3. So x, the hypotenuse, is 10 radical 3. Okay? Alright. This next one, number 2, says find the length of a leg in a 45-45-90 with the hypotenuse of 22. So the hypotenuse is 22. We know this is 45-45, so it's an isosceles. Or if you don't want to write that, you don't have to. You can write 45-45. Okay, so this time we're going from hypotenuse back to the leg. So that means we're going backwards. So then if we're going backwards, we divide by radical 2. So if you divide by radical 2, we are going, this is x and this is x. Remember, the legs are the same. So once we find one, we have found both. So we're going to divide by radical 2. So x equals 22 divided by radical 2. How we solve this is by rationalizing. We cannot have a radical in the denominator, so we rationalize. How we rationalize is we multiply the top and the bottom by radical 2. So the top would give you 22 radical 2, and the bottom would give you radical 4, but radical 4 is just 2. And then we need to simplify. So 22 divided by 2 is 11, and then we keep the radical. So each of the legs are 11 radical 2. 2 in this problem. Alright, the distance from one corner to the opposite corner of a square playground is 96 feet. So one corner to the other, one corner to the other corner, 96 feet. It's a square playground, so that means I've just made two right triangles in here. To the nearest foot, what is the perimeter? So, I need to figure this out. If this is a square, that means all the sides are the same. So if you look at it, that means you actually have two isosceles triangles that make a square. So if it's two isosceles, that means these angles in here are 45. So once again, we have 45, 45, 90. In order to find perimeter, we need to find all the outside edges added up. But all the outside edges are the same in a square. So the outsides of the playground is x. So in order to find the leg, the x, we go from hypotenuse to leg, which is going backwards. Whenever we go from hypotenuse to leg, that's backwards. So that would mean we divide by radical 2. So I'm going to come over here, and I'm going to do that. 96 divided by radical 2, and the radical is in the denominator. So once again, since it's in the denominator, we have to rationalize. So multiply the bottom and top by radical 2. And 96 divides by 2 evenly. That is 48. Goodness, that took me a minute, guys. Okay, so now we need to find the perimeter of the playground. So the perimeter is adding all of the sides up since they are all the same. Perimeter is going to be 4 times 48 radical 2. So perimeter equals, alright, I'm getting a calculator out. I don't want to do this in my head and mess it up for you. Radical 4 would be 192 radical 2. Now, we are talking about a playground. And in the real world, we don't leave radicals the same the majority of the time. So it also says in the instructions to round to the nearest foot. So I'm going to plug into my calculator 192 times radical 2. And I'm going to get an approximation. That's why I squiggled the equal sign. So 192 times radical 2 gives me 272 because it wants to the nearest foot. So I got to round up to the whole number. So the perimeter is approximately 272 feet. And yes, you have to use the squiggle equal sign whenever you round approximating an answer. Okay, that's all for 45, 45. The second special right triangle is a 30, 60, 90 right triangle. So in a 30, 60, 90 right triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is radical 3 times the length of the shorter leg. So the shorter leg is not always going to be visually the shorter leg like right here. So obviously that looks like the shorter leg, but you have to go based on the angles. And this one looks like the longer leg, and this is the hypotenuse. So in a 30, 60, 90, whenever we have this leg, we have to look for the opposite. So if that's the 30 degrees, the opposite's the short leg. And 60 degrees, the opposite is the long leg. So the theorem states that if you are going from short leg to hypotenuse, it's twice as long. So whenever we go forward, we multiply times 2. And the theorem also states if we go from short leg to long leg, we multiply times radical 3. You cannot, 100% cannot move from hypotenuse to long leg or long leg to hypotenuse. That is not okay. Does everybody see that? Not okay. Cannot go from hypotenuse to long leg or long leg to hypotenuse. You must always go through the short leg. Alright? And obviously if we go backwards, let me get a different color. If you move from hypotenuse to short leg, you divide by 2. If you move from long leg to short leg, you divide by radical 3. So if you want to write your theorems down, the hypotenuse is your short leg times 2. So 2 times the short leg. Your long leg is short leg times radical 3. The short leg has two equations. It's either the long leg divided by radical 3, or it's the hypotenuse divided by 2. So 30, 60, 90 triangles are a lot more intensive. Let's practice it. So find the lengths of the 30, 60, 90 triangle with hypotenuse 4, radical 3. So I'm going to give you that this is 30, this is 60, and the hypotenuse is 4 radical 3. So we need to label. This is opposite. Short leg is opposite of the 30. Long leg is opposite of the 60. To get to the short leg, we go backwards from the hypotenuse by dividing by 2. So I'm going to come over here, and I'm going to write down short leg equals hypotenuse, so 4 radical 3, divided by 2. So that would be 2 radical 3. And then to find the long leg, remember we cannot go from the hypotenuse to the long leg. That's not okay. So the long leg, we have to go from short leg to long leg. And in order to go from short leg to long leg, we multiply by radical 3. So the long leg is the short leg, which is 2 radical 3, times radical 3. So you do that, and you get the long leg equals 2 times 3. And therefore the long leg is 6. Alright, I want you to do number 5. If I tell you that this is 30 degrees, oh goodness, that's 30 and that's 60. Do this problem. Pause the video and do it. Okay, let's see if you got it correct. So if you notice, the biggest first thing right here was that I switched up the labels on you. So the 60 was your short leg, or was your long leg, which was 18. So across from it was 18, and the short leg was across from the 30. From going from long leg to short leg, we divide by radical 3. So I divided and had to rationalize and reduced it to 6 radical 3. And then once I got that, in order to go from the short leg to the hypotenuse, I multiplied by 2. So then over here shows my work for short leg times 2 is 12 radical 3. So hopefully you got that correct. Alright, for the next couple of problems, you need to go to the next video.